Did you know that to manufacture the cell phone you're holding right now, it was necessary to detonate explosives powerful enough to destroy an entire building? And that the copper wire inside your charger went through such extreme temperatures that they could melt almost any material? The journey of copper is one of the most impressive industrial stories, and you're going to learn about it today. Get ready to discover how ordinary rocks are transformed into the metal that literally powers the modern world. Look around you right now. Your smartphone, the computer, the wires in the walls, the air conditioner, the cables of the electric car in the garage. All these objects have something essential in common: copper. This shiny reddish metal is the invisible backbone of our civilization. Without it, we wouldn't have electricity, the internet, or technology as we know it. But where does this vital material come from? How do we transform rocks buried in the ground into one of the most valuable metals in the industry? Copper has almost magical properties that make it irreplaceable. It is one of the best conductors of electricity and heat found in nature. Only silver is better, but its cost is prohibitive. Besides that, copper is exceptionally resistant to corrosion. It is extremely flexible and malleable, and can be recycled endlessly without losing its properties. It is literally the eternal metal. The saga begins deep within the Earth's crust, where copper was formed millions of years ago in sedimentary rocks. But finding these deposits is not simple. Teams of geologists spend years conducting meticulous studies, analyzing thousands of samples, and using cutting-edge technology to identify areas where copper is present in economically viable concentrations, usually above 0.2% in the rock. When a mine is discovered, the spectacle of extraction begins. But there is a gigantic challenge. Before reaching the precious ore, it is necessary to remove immense layers of waste material. In some mines, the copper is more than 100 meters deep, requiring colossal machinery and tons of explosives. The extraction process looks like something out of an action movie. Giant drilling machines make about 130 holes in the ground, known as blast holes. Each hole is at least 16 meters deep, the height of a 5-story building buried in the earth. Inside each hole, technicians insert a powerful explosive mixture of ammonium nitrate and fuel. In addition to iron foe, a high-powered industrial explosive. From a safe distance, an operator triggers the detonations in sequence, with intervals of just 2 milliseconds between each explosion. Each detonation releases enough energy to demolish an entire building. But it's not chaos. This explosion pattern is carefully designed by engineers to fragment the rock in the ideal way, maximizing copper extraction and minimizing the dispersion of material. After the explosions, the colossal excavators come into play. These gigantic machines lift up to 80 tons of rock at once, the equivalent of 250 cars. And here's the impressive fact. This rock contains only 5% copper. To obtain 1 ton of pure copper, it is necessary to extract and process almost 200 tons of raw ore. The material is loaded onto mining trucks, which are nearly 7 meters tall and can carry up to 400 tons. Since open-pit mines are enormous, the entire operation is managed from a control center in a tall tower, similar to those at airports. There, operators coordinate dozens of machines simultaneously via GPS. Now the real chemical transformation begins. There are 2 types of copper ore: oxide and sulfide, each requiring completely different processes. For oxide ore, the leaching technique is used. The rocks are stacked in special areas and irrigated with a diluted sulfuric acid solution. For weeks, this acid seeps through the rock, dissolving the copper. The solution, now loaded with copper ions, is collected in tanks and taken for processing. At the processing plant, the copper solution is combined with an organic reagent that floats on the surface, separating the copper from other substances. Then, a concentrated acid solution is used. This further increases the purity and makes the copper electrically conductive. This solution is transferred to special tanks containing thin copper plates called cathodes. When an electric current is applied, the copper ions migrate and deposit onto the cathodes, atom by atom. In just 10 days, each cathode accumulates a layer 2.5 centimeters thick. The achieved purity? Impressive. 99.99%, essential for high-performance electrical products. For sulfide ore, the process is more complex. It all starts in gigantic mills, where steel balls crush the rocks into microscopic fragments. The material passes through sieves that separate different sizes. The larger pieces go back for further grinding until everything is finer than beach sand. Once pulverized, special chemicals are added, coating the copper particles and making them hydrophobic, repelling water. The mixture enters flotation tanks, where compressed air creates millions of bubbles, which carry the copper particles to the surface, forming a foam rich in metal. This foam is collected and filtered, resulting in a concentrate with at least 30% purity. The concentrate travels by train to the smelting plant, where it is mixed with silica sand, known as flux. In furnaces at extremely high temperatures, the mixture turns into a glowing liquid. The slag from iron and other minerals floats, while the denser copper sinks. At this point, the purity already reaches 60%. In a second furnace, the content rises to 98%. The liquid copper goes through one more furnace for final purification, reaching 99% purity. It is poured into molds, forming large rectangular plates called anodes. These plates are cooled with water jets, solidified, and automatically transported for cleaning before being sent to the refinery. In the refinery, the anodes are immersed in tanks with electrolytes, positioned in front of metal sheets called cathodes. When an electric current is applied, the pure copper transfers from the anodes to the cathodes, while the impurities fall to the bottom of the tank. The result? Copper with almost 100% purity, perfect for the most demanding cables in the industry. This ultra-pure copper is melted in vertical furnaces and molded into rectangular blocks about 6 meters long. The molten copper passes through an opening in the mold and is cooled with water, forming a continuous bar. Special rollers progressively reduce its diameter until it becomes a rod about 7 millimeters thick. The rod leaves the system and is wound into a spiral shape. A machine compresses the coil to save space during transport. This spool of pure copper will be turned into conductor wire, ready to carry electricity and connect the entire world. And that was the incredible journey of copper, from underground explosions to the wire that powers your home. If you enjoyed this content, don't forget to leave a like, subscribe here to Linha de Produção, and turn on notifications for more fascinating videos about industrial processes. See you in the next video!